Right. Right. Okay. So, to be like Bruce Lee, I've got to do... Okay. Then from there, I've got to make bird noises. Bird noises. But it doesn't specify. Okay then. Do you think that's working? Hi, Lester, Wushu Engineer. Shad recently posted a video critiquing Nunchaku, also called nunchucks or simply chucks. I encourage you to check out his video for context because I'm not going to provide too much more of that in this video. When you're there, I encourage you to check out the rest of his excellent and entertaining content. In my experience, Shad is a generous and courteous gentleman, and I always appreciate his perspectives and his points of view. In his nunchucks video, Shad refers to an earlier video that I posted in response to one of his older videos on the medieval flail. I really appreciate the shout out from him, and I commented on his nunchucks video and said that I could perform a set of comparative tests between a set of nunchucks and a simple stick. He said, "That would be awesome to see, mate. If you do test, please send me the link." So here we are doing this thing. Before I carry on with the video, I would like to do a few things. Firstly, I'd like to welcome my new subscribers. Please make yourselves feel at home. I really appreciate subscriber comments, requests, questions, and even criticism when delivered constructively and when backed up by good, hard science and data. No one is infallible, and I do make mistakes, although I endeavor not to. However, do be prepared to back up any criticism with hard science results and facts. I don't take pseudoscience and mere opinion seriously, and I expect civility in the comments section. I don't typically respond to impolite and uncivil comments. I would also like to present some of my background as a bit of a personal introduction to my new subscribers and to add context and relevance to this video. I'm a chartered, registered professional electrical engineer and part-time inventor. I've been building and inventing things since I was actually just a wee lad. I have a very keen love for science, and I'm very closely involved with developing methodologies, training programs, and new prototype equipment for our martial arts research and testing laboratory, and to support my wife, the Wushu scientist, in her studies. She's currently engaged in her PhD research study through the University of Southern Queensland. I've also been training seriously in martial arts and various physical disciplines for more than 30 years now. And I've spent more than 20 years dedicated to training in and teaching my system of traditional Kung Fu or Wushu called Chang Hong, as taught through the Chinese martial arts and health centers worldwide. Although my weekly training hours have varied over the years and from one training cycle to another, and although I do take a light week every 5th week, on average during normal training weeks I train anywhere from 20 to 40 hours and have done so for the last 2 decades. I've been taught martial arts and self-defense by some of the same people who taught combat techniques to elements of the old South African Special Forces during the Angolan Bush War of the 1980s. So although we train and teach a very traditional system of Kung Fu, our focus is always on real-world, pragmatic application of traditional technique to combat and self-defense. In terms of weapon use, nearly 50% of our system curriculum is weapon-based, so I have a very good understanding of how to use weapons. In fact, I currently hold the striking record using a baseball bat on the Power Cube device, which is one of the most advanced human striking measurement systems that's currently commercially available. This is a record that I set at the cost of my Louisville Slugger baseball bat, which cracked during the record-breaking strike. I'm also a confirmed sci-fi and fantasy enthusiast and a dyed-in-the-wool tabletop role player who lived and played through the nonsensical media-driven frenzy of the 80s and early 90s, during which role players were often shunned and accused of being members of weird cults. Tolkien, bless his soul, got me through some pretty tough times in the old South African school system, where nerds like me were often targeted by bullies because we were different. So hopefully that gives sufficient background to set the stage for this video. After I saw Shad's first video, I secreted myself away in my secret lab workshop for a couple of hours, and I built this set of Nunchaku, keeping as close to the traditional norms as possible. The sticks are just over 30 centimeters in length, and they're joined by a 15 centimeter set of cords. Of course, there are variations in these measurements in the traditional weapon sets, but these are fairly close to the norm. However, the wooden pole that I used to make the chucks was quite thick. So in that regard, it may be a bit of a deviation from the traditional chucks. The wood is some kind of native Australian gum hardwood used for tool handles and is very hard and very heavy. I got it in the sporting goods department.
You can find this in the sporting goods department.
Nah, actually it was at Bunnings. I referred to a traditional Nunchaku kata that is available on YouTube and took from this kata a simple over-shoulder strike to use in the testing procedure. The kata I referenced is Nunchaku kata number 1 on the Shaolin Wave YouTube channel, although the clip does appear on numerous other channels as well. I chose this particular kata because there were no pointless flowery or showy movements in it, and it was clearly meant for the business of fighting, not entertaining. I might add that it was extremely well performed as well. I used a different piece of wood to construct the simple stick that I was going to be using in the comparative tests to ensure that the weight of the two weapons would be as close to identical as possible while still being the same length. The simple stick was well within the length parameters for our traditional flute weapon, so I'll simply refer to the stick as the flute from now on. Although the traditional flute form was developed to suit the traditional Chinese flute known as the Dizi, and I'm probably butchering that pronunciation, which is typically very fragile, we typically use solid wooden short poles to train and spar with. I will use simple over-shoulder strike directly from our traditional form that is functionally identical to the Nunchaku strike. So these are the two weapons. The Nunchaku, which I made according to traditional guidelines and norms, and normal parameters, except perhaps for the weight. They are a bit heavy and chunky. And then the flute, which is approximately, it's within the range of a traditional flute's length, except, yeah, again, a little bit chunkier. But this weight, the weight of this is almost the same as the weight of the Nunchaku. So if I better do the weigh-in now. We'll do the Nunchaku first. And the Nunchaku weigh in at 627 grams. And the flute weighs in at 626 grams. So out by 1 gram. I think that's pretty much close enough to call it even Stevens. Both of these weapons will be covered with a foam sleeve just to protect the top of the load cell, or top of the impulse block setup's foam spring. Yeah, nothing more than that. At this time, I would also like to mention a comment that came through recently on my flail versus mace video that had a lot of merit to it. Thank you for your comment, and I actually agree with you on that point. However, what you propose would represent quite a large and time-consuming and quite detailed study, which is really outside of the scope of a typical YouTube video. I already get people complaining that my videos are way too long and boring as so for the purposes of this video, we are simplifying the tests to keep all things equal as far as possible and do a direct comparison. I believe the results will still be relevant as long as it is understood that this is a test limitation, that the parameters of both weapons were kept as consistent as possible. The method that we're going to use to test the striking effectiveness of the chucks and the flute is the impulse block method. Now, the impulse block method and equipment was designed to support the Wushu scientist's current PhD research project. This project involves measuring the effects of a modified Qigong breathing training program, I should say, on physical strength, load-bearing performance, spinal unloading, and striking effectiveness of military personnel. It also now forms the part, so the impulse block method also now forms the part of the testing and training services offered by the Martial Arts Research and Testing Laboratory, or MARTEL. For a more comprehensive description of the impulse block method and equipment, see my dedicated video on the subject. Suffice to say here that the impulse block method relies on measuring the force per unit time data of an impact using a load cell fitted with a specially designed foam spring, performing numerical filtering on the data, and then integrating the curve with respect to time to yield the impulse of the impact. Impulse is, of course, the change in momentum and would represent the change in momentum that a target would experience as a result of an impact. The simplified impulse block method involves just retaining the impulse of the impact and the impact duration to describe the impact sufficiently for comparative purposes and for the purposes of tracking a combat athlete's striking KPIs. However, our impulse block method is also provided with a laser photo gate timer that I designed and built, which measures the impact time in microseconds over a 1 centimeter gap just above the foam spring of the impulse block. I will put out a separate video describing the design and construction of this laser photo gate timer at a later date. There were no other timers actually available commercially of this nature anywhere to our knowledge, actually, which is what necessitated its design and construction. The time of flight data of the object crossing the 1 centimeter gap allows us to calculate its approximate instantaneous impact velocity just prior to impact. With these three quantities, impulse, impact velocity, and impact duration, we can calculate a whole slew of very interesting quantities, such as the numerically filtered impact force, the kinetic energy of the impact, the power of the impact, and the apparent mass of the impact. Apparent mass is a very poorly understood quantity in striking and represents the mass that is channeled into a strike. This is very difficult to model mathematically because of the mechanofluidic nature of the human body. However, using the impulse block method, we are able to calculate it directly, or at least to measure parameters that allow us to calculate it and examine it. So using our impulse block setup and method, we'll be able to analyze the parameters of the Nunchaku and flute strikes in greater detail than any other human striking measurement system available to our knowledge. So this is the impulse block equipment setup. Underneath you can see the load cell, and on top of the load cell we have the impulse block foam spring, and in this corner we have the microsecond timer. As you can see, very chic 80s electro punk look to it. It's a prototype, so that will be upscaled and made to look real schmick. at some stage. Over there we have the two lasers separated by 1 centimeter gap, and on that side we have the photo transistors, which are the receiving end. So well, first of all, I'll say that this frame, it's not ideal to have it mounted on the front plate of the load cell, and I need to shift it onto the lower support plate of the load cell, but I'm not going to do that for this set of tests, specifically because it'll take me some time. I need to get more materials to do that, and also because since this is a comparative set of tests in which this will be mounted on the front plate for both sets of tests, it shouldn't impact the comparative results between the Nunchaku and the Flute. Just to show you the operation of the microsecond timer, I'll just break these beams, and as you can see, that represents the number of microseconds that it took me to break those two beams that are 1 centimeter apart. As you can see, I took an awfully long time to do that, and this is just the reset. The load cell will be connected to the laptop over there, which will be sampling data from the load cell at 1 kilohertz, and just for comparison, as I mentioned, the load cell is sampling data at 1000 hertz, 1 kilohertz, and this piece of apparatus here of my construction is actually timing at 1 megahertz, so significantly faster.
A set of tests like this would be incomplete without discussing the sources of error. All tests are subject to error from various sources, typically from measurement limitations. This set of tests is no exception. However, in this case, because human performance is being analyzed, the greatest source of variation in the tests would come from my natural human performance variation. Despite the fact that all equipment used in these tests has been calibrated, in the load cell's case, independently calibrated by the university, there are still error margins associated with these measuring devices. However, the error associated with the measuring equipment is so small in comparison, typically, with human performance variation that it can essentially be ignored. In addition, because these are comparative tests, equipment measurement errors will be consistent within both sets of tests, which means that they will have a negligible effect on the comparative results. Before we go on to the actual Nunchaku versus Flute tests, I would like to test something that keeps on coming up in the comments on my flail video, and which I feel will most likely come up in comments on this video. Some folks seem to have a rather cartoony concept in their minds about how rotational energy can continuously be imparted by a wielder to a weapon like a flail by spinning it round and round and round and round fast before striking. I think that in many of these cases the commenter has simply never gotten out of their proverbial armchair to test this hypothesis. In other cases, I believe that they may just have assumed that this works in practice without actually performing actual scientific tests to determine whether this concept was grounded in reality. So we'll ignore the very obvious strategic and tactical problems associated with the time spent fooling around with trying to get the weapon up to optimum rotational speed while one's opponent or opponents are poking one with sharp sticks, and concentrate on whether that concept even works with human biomechanics. Because of the laser photogate timer and the instantaneous impact velocity calculation potential offered by the impulse block setup, I will use a simple arrangement of a tennis ball in a bag on the end of string and test whether I can get higher impact velocities from spinning the thing as fast as I can before striking than from a single swing.
So I'll turn on the timer, make sure that the lasers are aligned and working. Yep. So we're just going to be looking at impact velocity for this. The load cell is disconnected, and at first
I'm going to try a couple of strikes where I'm just striking overhead, one single swing. So that was 560, 522, 542, 489, 467. So now I'm going to do the spinny one and try and spin it as fast as I can and then strike. 474, 692, 545, 523, 492. So as you can see from these tabulated results, there was no additional benefit gained from spinning the tennis ball repeatedly prior to impact. In fact, if anything, there was a drop in average impact velocity in comparison to the single swing tests. However, due to the significant variations between strikes, I believe that it would be safe to ignore this drop and merely conclude that spinning a weapon repeatedly prior to impact will be unlikely to increase impact velocity over a single swing. The human body just does not work like a motor, which of course is a very efficient and specialized rotational machine. In addition, a person wielding a weapon like the flail or nunchaku, for that matter, sets up an unbalanced rotational system when they swing the weapon, because of course the weight is really only on one end of an arm. This requires a great deal of energy to be expended to stabilize the point of rotation and act against the centripetal forces at play. As such, the amount of rotational energy that can be stored by a human wielder in a weapon like the flail or nunchaku pretty much reaches its maximum and then plateaus shortly after the first swing. Thereafter, all of the wielder's energy and effort goes into stabilizing the point of rotation, and pretty much none is added to the spinning object. So cool-ass spinny movements should remain where they belong, in cartoons and flashy performances, and not on the battlefield. Then on to the nunchaku tests, which look like this. Okay, so what I'm going to do is I'm going to use a traditional type of strike, which comes from over the shoulder, over the left shoulder, down, and then the rest of the rotational or kinetic energy is absorbed by the arm swinging around if you don't hit a target. In this case, I am going to. So, in the interests of safety, I'm going to be dressing up a little bit like one of the village people with my old sight helmet. And goggles. All good. So we're going to just ensure that the lasers are all zeroed. System is picking up. Yep. Okay. The Wushu scientist is going to start the load cell software, zero it, and then she's going to clear out a dodge.
Zero.
Okay. Strike one.
Zero.
So strike two. So we'll go for strike three.
Okay, so start. Zero. Start. Zero. Here.
From these, I went on to test the flute. Unfortunately, the first test did not go well. So with the flute, I'm going to use a functionally identical strike from over the shoulder. This is from our flute form, where the flute is drawn back for a second strike in the just after the greet, but functionally identical to the strike that I've just used with the Nunchaku. Same biomechanics. Okay. Better play dress up. Don't think I need the helmet this time, unless something catastrophic happens with the flute. Line the lasers, reset, check the system is working. Yep.
Start. 0.
Okay.
That's 1291.
And interestingly, my flute is broken.
Oh no.
Oh dear. Well,
To be continued.
that's this life, people. That's this life. Okay, so there was some foreboding in my words about catastrophic failure of the flute. So unfortunately, I hit it a bit too hard and shattered the piece of wood that I found. That I took great pains to try and find one that was identical in weight. Unfortunately, it didn't live up to my expectations. So we're going to have to go with this. Now, this is made out of the same material as the Nunchaku. It is the same length as the Nunchaku, but because it contains obviously more wood, the center section is not removed clearly, it is heavier. So if I do a weigh-in of this, it is 814 grams, so nearly a kilogram. And this is just going to have to be one of the limitations of this test, that this is a different weight. But it is what it is, people. I'm sorry. So now we're going to try take 2 with this chunkier flute. We'll turn this on, ensure that the lasers are aligned, reset. Make sure that it's functioning, yep. Okay.
Start and 0. Start and 0.
Dokie. I have not gone through all of the steps in this video performed during the data analysis, because this video is already way too long, and this would push it to a ludicrous length. I checked the clock frequency of the laser photogate timer when we did the tests and found that it had drifted slightly and was out to 977 kilohertz. So we have incorporated that figure into the impact velocity calculation to get the true value of the impact velocity. These are the tabulated results for the Nunchaku and the new flute tests. Many folk tend to be overly reductionist in their thinking, oversimplifying the statement of results and conclusions because they want fast food answers to life's questions so that they can forget about the questions and get on with their lives. This can lead to the proverbial baby being thrown out with the bathwater. So I believe that this should be avoided. The wushu scientists and I face that kind of attitude a lot in our ongoing investigation into the subtle biomechanical and physiological reality of the phenomenon known traditionally as qi, or ki. Studies that have already revealed some very significant scientific findings. I would thus like to keep a broader perspective on the results. However, I believe that there are some conclusions that we can draw and some observations that we can make. Firstly, I'd like to say that I was actually very surprised by the results. I fully expected there to be more of a difference between the two weapons in favor of the flute, based on my older investigation into the mace versus flail. However, the results were pretty damn close. Subjectively, I feel that this may be to do with a far more even weight distribution in the nunchaku than when compared to the flail, which has a lot of weight in the striking head, making it feel a lot more awkward to use. Perhaps it would be taking things a bit too far to say that the nunchaku and its variants, like the three-sectional staff, may be classed as superior flail-like weapons over the weighted flail. So I won't say that. On a general note, the impact velocities of both weapons were in a similar range, with the impact velocity of the nunchaku being slightly higher. I did a couple of bare hand tests using an overhead hammer hand strike, just to examine the impact velocities.
986.
As you can see from the tabulated results for my hammer hand strikes, my impact velocity, which was close to 10 meters per second, was only about half the impact velocity achieved by the weapons. This is one of the advantages inherent in using longer weapons, which can lead to improvements in striking kinetic energy. The impact velocity of both the nunchaku and the flute were similar, with the nunchaku reaching an impact velocity of about 18 meters per second. To put this into context, you would have to drop an object from nearly 4 stories up in order to achieve this kind of free fall velocity. The impact duration and impulse of the flute were higher, due in part to my ability to maintain a short duration pulse of sustained force to improve the contact duration. However, the apparent mass behind the nunchaku was actually surprisingly identical to the weight of the weapon, whereas the apparent mass behind the flute was lower than the weapon mass. I was surprised by these results, fully expecting the apparent mass to be higher behind both weapons. But there's often a trade-off between velocity and apparent mass in an impact. It's difficult to channel apparent mass into a weapon through the rather fragile link through the wrist and grip of the wielder. It's far easier to channel this into bare hand strikes. However, as has already been seen, impact velocity is negatively affected. The kinetic energy of the flute was higher than that of the nunchaku, but the nunchaku's power, which of course is dependent on how fast the energy is delivered, was higher. So one could say that the flute strikes transmit more energy, but the nunchaku are more powerful. The numerically filtered peak force of the flute was significantly higher than the nunchaku though. Although impact force is a measure that is very much subject to the nature, rigidity, and or elasticity of the materials that the impacting objects are constructed of, it's still a relevant parameter to look at in this case. So the flute struck with far more impact force. It's clear from these tests that at least in some regards I can strike harder with the flute than with the nunchaku, though the results were pretty close. Does that mean that the flute is a better weapon than the nunchaku? Well, if we're looking at striking effectiveness, then perhaps yes. Can the nunchaku strike with sufficient force to break bones or to render someone unconscious? Of course. But can it do that more effectively than a flute? Possibly not. In addition, there are other considerations in the use of both weapons, which Shad accurately picks up on in his video on the Nunchaku. One is that it is more difficult to control a battlefield in terms of range using a flexible weapon. Another is that the defensive potential of the Nunchaku is likely more limited than that of the flute. And finally, there is the unpredictability of the weapon. Of course, this unpredictability can be offset by rigorous training. But remember that this rigorous training will typically also affect the user's ability with simpler weapons as well. As an example, through rigorous training, I can offset the instability that is inherent on standing on one leg, for instance. In fact, I can offset it so much with the traditional Kung Fu training and biomechanics that I may actually become more stable on one leg than an untrained person is when standing on two. However, I will always be more stable standing on two legs than on one, so the inherent instability never goes away. The chance of misreading the Nunchaku may be almost completely eliminated by training, but it can never be fully eliminated. You can always roll a critical fail. There are pros and cons to both the flute and the Nunchaku, but the flute will always be simpler to use because it is a simpler weapon. I would also like to inject some further nuance into the discussion. In my traditional Kung Fu system, there are a great number of weapons that we train with and that have forms associated with them. As an example, we train with a fan. Is a fan a more effective striking weapon than a Nunchaku or a flute? Absolutely not. However, the fan became part of the traditional weapon set because there were situations in which this was the only weapon or weapon-like item that could be carried, such as in the court, for instance. So in a situation where you can only carry a fan, it makes a far better weapon than none at all. So best to train with it. I could even go one step further and say that in our system, like in many other Eastern martial arts, there's a heavy concentration on bare hand fighting. Would I rather fight bare hand than with a weapon, even a substandard weapon? Absolutely not. We train bare hand fighting extensively because it is the worst case scenario, and we always train to be as effective as possible, even in the worst case scenario. But I would not choose to place myself in that scenario if I had a choice. Sure, one can break bones, snap tendons, or cause internal hemorrhaging with strikes, but one could typically still be far more effective with a weapon. Nunchaku, flutes, spears, fans, umbrellas, small wooden benches, hairpins, all of these weapons had or have their time and place. There are countless examples of situational and legal restrictions throughout history that limit the carrying and use of potentially superior weapons. Our current day and age is full of those examples. Here in Australia, for instance, it's essentially illegal to carry any weapon for the purpose of self-defense. Yes, even those silly little keyring things. I've received helpful comments from some Americans on some of my videos analyzing the self-defense potential of various non-weapons to the effect of, I just carry a gun. Well, thanks, mate. I would too if I could. A handgun in the hands of a well-trained individual represents pretty much the apex of available self-defense weapons. However, I cannot carry a handgun here in the land of Oz, and even owning one is fraught with so many difficulties that I don't even consider that it's worth it. So I carry flashlights, pens, umbrellas when appropriate, briefcases, carry bags, and other associated non-weapons that can be used for self-defense purposes in a pinch. Are they more effective than a handgun? No. But I can carry those, while I can't carry a baseball bat, or a sword, or a shotgun, or a taser, or pepper spray, or my old CZ-75 9mm that I used to carry in old South Africa. Well, this was a particularly long video, so I apologize for the length, but there was an awful lot to get through, and thank you if you made it this far. I hope you enjoyed the video, and I'll see you all again next time. Cheers.